Okay. So, dear Esther, we have been discussing some important topics for databases and SQL, and we have discussed definition and some types of databases, then what is SQL, then DBMS. I think it's new thing. DBMS is a software, database management system is a software. For example, yesterday we were discussing there are different type of softwares. For example, MySQL, PostgreSQL, Microsoft SQL Server, or we can add some other, for example, MS Access and Oracle. All of these are DBMS, database management system. All of these are softwares. A DBMS is a software that enables the creation, maintenance, and use of databases. So by using this software, we can create, we can manage our databases, and then we can create tables in it and so on. So popular DBMS examples are MySQL, Oracle, Microsoft SQL Server, and SQLite. But believe me, the list is going on. There are a lot of DBMS uh, running all over the world. So next is creating a database, and we have discussed about schema. Schema is a structure of database, is defined sorry database is defined by its schema, which outlines the tables, columns, data types, and relationships. So the next is primary key. Primary key, the concept of primary key is very important. Rather, you can consider there is a broader concept of keys. So keys are of different types. For example, there could be a super key and candidate key, although concept is very broad and there are a lot of different concepts, but we can focus over very important uh, thing, alternate key, and then primary key. Now let me tell you what is a primary key. For example, in every country there is a national identity number, or there is a national identity number, or there is a social security number, or any, so for example, your Gmail account, your cell phone, all of these information are unique. No one can have the same Gmail account as yours. For example, if my Gmail account is this, uh, then no one can have the same Gmail account. So these type of columns, these type of values are known as primary keys. Fine. And by using these type of values, we can identify our complete row in our table as a unique record. Fine. A primary key uniquely identifies each row in our table, ensuring data integrity. This way we can ensure our data integrity. And you remember, I have shared with you, I have opened some slide. So you can see we have discussed in yesterday's session about this relational data model, or and you can see there are different tuples, and tuples is a technical name for records. So you can see there are different rows or records, and all of these records are uniquely identified by this column, which is SSN. And this SSN cannot be same for even for two different persons. So this type of information or column can be used as a primary key, which never ever can be same. So what this primary key does for databases, a primary key uniquely identifies each row in a table. For example, it's a table. If there are millions of records, then even then this SSN definitely is unique. And the same thing is with national identity number, and in different countries this national identity number is called as in a different way. For example, in our country it is called as CNIC, computerized national identity card, but in different countries this number could be called in a different way. But the common thing is that those numbers are unique. Fine. So we can use this type of information for as a primary key, and this primary key will uniquely identify all of the rows in a table. So and we must have a primary key in our table. We must have a primary key in our table. And you remember from previous discussion, technical name for table is relation. And by this name we are saying it's a relational database or it's a relational data model. Okay. So the next is retrieving data with SQL, because I have told you that SQL is a query language. Let me write here. SQL is a query language, must be used for all the relational databases. Rather, I can say there is single option available for relational databases. We have no choice. So you can imagine if there are thousands of DBMS, if there are thousands of relational databases, and the choice is single, which is SQL, then how much it is important. It is actually, structured query language. So we will see little queries for this language in today's session. Okay. Then for retrieving record, for getting records from the table, we use select statement. Fine. Use the select
Mm-hmm.
statement to query data from a database. Rather, I have written some SQL commands separately. For example, if I'm going down, you can see there is a select command, general syntax for select command. We have to use select keyword. Then we have to name different columns, whatever we want to retrieve. For example, from this table, if I want to get only uh, okay, if I want to get only name and address, then I can write here name. For example, I can create some new query for retrieving some records from this table. I want to retrieve name and address only. I can write here select name, comma, address. Now, from is a compulsory keyword. I have to tell from what table I want to retrieve records. From, because this table is student table, so I have to write the name of the table, which is student. Then fine. By writing only this command, this SQL query, I can I can get all of the students, all of the names and address for the whole table. But if I want to get some specific student, then I can use where clause, and this where clause is used for restricting the number of records. For example, I can write here where SSN, for example, because SSN is a primary key here. So if I am writing SSN, then it will return us only a single record. For example, I am saying 305612435, 30561 and 2435. So this way we are writing SQL queries. Fine. Whenever I will run this query, it will return me a single record. So these are some it is some way to write SQL queries. So we were discussing about select statement. About SQL, we can retrieve record by using select statement, and we can filter by using where clause, and I have discussed a simple query with you. And then we can combine, we can get records from more than one table by using join, and there are different types of join: inner join, left join, right join, and there are a variety. Then we can insert, update, and delete records. For inserting, I can discuss from here. For example, for inserting, we can use query insert into, just like this way. We were saying select this and this from this table. So for inserting, we can write insert into, then table name, then further. For example, you can see the general syntax: insert into table name, then there are different columns. So let me write some query for this table. For example, what I have to do, I have to write here insert into, the table name is student. Then I have to write column names. For example, there are 1 2 3 4 5 6 7 columns: name, SSN, home, phone, name, SSN, home, uh, phone. Then there is a address, then there is a office phone, address, office phone, age, then GPA. After writing names of columns, I have to use keyword, which is values. Then I have to write values for each of the cell or each of the column in the same sequence. For example, first of all, I have to write name, and for example, I can write your name, and then comma, then SSN, and we have to follow specific format. And you can see SSN is in 3 digits, then hyphen, then 2 digits, then hyphen, then 4 digits. For example, 3 digits, then hyphen, then 2 digits, then hyphen, then 4 digits. Then I have to write home phone, and we can follow some specific structure. Fine. Then address, and we can write different and so on, whatever the address is. Okay, so then after address, there is a office phone, then age, then there is a GPA, for example. So this way we are writing insert into query. I am just doing bold some keywords. For example, insert into a keyword, then values is a keyword. And keep in mind, we can write all of the columns. On the other hand, we can leave some column according to our requirement. For example, you can see this home phone. You can observe from this example, this home phone is not compulsory, so here is null. Further, office phone is also optional, here is null. So what we can do, just for just for making some other example, I am copying this one, and we also can write this way. If there is no phone available, then I can skip this column, so that I have to skip also uh, this office phone number, and automatically there will be saved null. But we have to mention these things in schema, what we have discussed in little detail tomorrow. And schema is a schema is a thing which can discuss about the structure of the table, about the columns, and what type of data could appear into the columns. So we have to discuss these things in schema anyhow. So we can insert, we can retrieve data, we can insert data, we can update data, we can delete data from the tables. Then there is a data integrity. Now, what is meant by data integrity? We have to impose some constraints over our databases so that our data remain in a good form. What is meant by good form? Yes, it's a very good question you are asking for. What is constraint? For example, if this SSN is a primary key, then I can it is a natural constraint over primary key that primary key never be empty, primary key never be null. On the other hand, I can give you some more examples for constraint. For example, I have to write the phone number in some specific format, for example.
Oh,
For
okay, I
example,
get it. So
yes,
constraints are basically the rules for that specific.
limitations, limitations,
Yeah.
limitations and
So
bounds on
so
entering data. Fine.
so it's like being on a user interface and it's saying like
Yeah, yeah,
this section has to be filled out like where there's
yes.
optional sections and then there's
and
sections that
and and let
actually.
me let me add here, all of these constraints must be discussed and imposed using schema. Fine. So schema is very important thing. I can add this into notes. So I will share updated notes with you. So so if I have some schema constraints, that phone number should be in this format, first of all 4 digits, then hyphen, then 3 digits, then hyphen, then 2 digits. Okay, no issue. Okay. So these type of formats are uh, known as constraints. For example, you can see a GPA column. We can never write some characters in GPA. In age, we cannot write, for example, ABC, ABC, and we cannot write GPA like this. Fine.
Okay, so
So
it's the rules of the text, right?
yeah, these are constraints, these are limitations and bounds on entering data. But constraints are more than that. So because whenever we are dealing with databases, whenever we are writing some schema for our database, then we can discuss more. But I have told you that this is a full course, and I have shared with you, it could be discussed in one semester, or uh, in undergrad degree. Believe me,
Mhm.
there are minimum couple of courses for covering database concepts. One course might
Mhm.
be for database management system, and other one for database administration, or database management. So it is a very huge topic. Okay. So next is after constraints define constraints, e.g. unique, and primary key is unique. you know Primary key is always unique. Fine, not null. For example, we can impose this constraint over name. For example, we can define all of these constraints as per our requirement, as per a requirement from the organization. I can say name never be null. Fine. And I can also say the same way, cell phone never null. So all of these things are constraints. Okay. To enforce the data integrity rule, so these constraints are there for maintaining data integrity. This way data will be in good form. For example, let me give you some scenarios, some example. If everyone is writing GPA in his own way, so someone can write 3.9, which is definitely a good way, 3.6, and the other one is writing this way, 3 and half. So so this way data is not maintaining integrity. Fine. Someone is writing age like 29, and other one is writing as uh, 20. So it is not data integrity. So we should impose some constraints to maintain data integrity. Okay. And all of these constraints must be discussed and imposed using schema. Schema is a thing which is used for imposing all of these uh, constraints. And you can discuss, you can check what was the definition of schema. Let me find. This way uh, yes, you will be satisfied by discussing this definition. The structure of database is defined by its schema, which outlines the tables, columns, data types. Now data types are the values which will be appear in columns, and relationships, everything is defined in schema. So data integrity, then transaction. Now what is transaction? Whenever we are inserting some data, we are running this insert query, we are running some update query, we are running delete query. By running these queries, we are performing a single transaction. Use transactions to ensure that a series of SQL statements are executed as a single atomic unit. uh, SQL statements are for inserting data, for updating data, for deleting data, or there could be some other type of transactions there. Okay. Then there is a indexing and optimization. Just like primary key is also a type of a little type of indexing, but we can create some more indexes in our databases for retrieving and storing data in a quick fashion, in an efficient way. So these indexes are working like primary key, but different from primary key. So create indexes on columns for faster data retrieval. Just like I can tell you that from just checking this state of table, I can say this SSN is a primary key. So we can create some index over different column over, for example, GPA, over age, for retrieving records in a efficient way. Then there is a normalization. Normalization is another very comprehensive concept, and it also uh, used for maintaining data in a good health. So normalized database design to minimize redundancy and optimize storage. Now, what is meant by redundancy? Redundancy is the synonym for redundancy is repetition. Redundancy is a technical word, although, but the synonym for this word is repetition. Fine. So this normalization ensures there should be no repetition in our database. Repetition. Fine. Okay. Fine. And optimize means working efficiently. Okay. Optimize storage, then security. If we are accessing our DBMS by some username password, then it provide us security. Just like you can see access control. Access control is achieved by, username passwords, by different user roles and permissions to control who can access and modify data. Then data encryption is a uh, as your background is from security, then you are well aware about data encryption. It's a way to uh, keep our data in a secure form, and by doing encryption, we can change the form of the data so that only authorized person can read and understand our information and data. Fine. Then we can take backup, and as per requirement we can recover our database according to the needs, because it's a good way to take backup. If the system is crashes, then we can recover that database. Then there is a SQL, and we will discuss SQL in detail by following this stuff. Then after SQL, there is a resources for learning online. Different resources are there. So it was some important concepts for databases, and further we can discuss in little detail structured query language. And I think it is enough for today, as time is going over, and we can discuss more in next session.